So, bottom line here, who's the 8 expert? Matt, what happened?
I was confused by this one. So,
can you just tell me basically what you think happened?
what I think happened.
There's fluoride.
There is fluoride. And basically, I looked at the last sentence, fluoride concentration.
Wait, you just looked at the last sentence?
Well, no, but like.
Fast forwarding, okay, yeah.
Yeah, I was focused on the last sentence
Okay.
when I was going through my answer choices.
Yep.
That fluoride concentrations in groundwater are higher when there's sodium.
Yes.
So.
In the water, right? I think that's significant.
Yeah, in the groundwater. So I incorrectly chose E. There.
Soil that contains high concentrations of sodium-bearing minerals also contains high concentrations of fluoride-bearing minerals. Do you guys? So I think there's 2 problems with E. Any guess what they are?
It's focusing on like.
I think this kind of a discrepancy question.
Like this, like the paragraph.
You don't know what the paragraph is saying. Okay, let me just draw it for you really quick. We have soil. Naturally. Nice. We have groundwater. Again, naturally. What happens? Rain comes down, right? And it says when it dissolves the fluoride-bearing minerals in the soil, it enters the region groundwater when the rain... So the rain comes down and it messes with the fluoride-bearing minerals, right? What was it? Fluoride-bearing minerals. So there are minerals in the soil that have fluoride attached to them. Sound good?
Mm-hmm.
Okay. The rain dissolves it, so it becomes separated, and then what happens?
And then I'm assuming the sodium comes into the water?
It says researchers found that when rainfall, concentrations of fluoride-bearing minerals and other relevant variables are held constant, fluoride concentrations in groundwater are significantly higher. So apparently it's coming down here, but the fluoride concentrations are significantly higher when all the things are held constant, but you have higher amounts of sodium in the water. So if you hold the number of fluoride-bearing minerals constant, you say that, hey, look, if we look at places that have 100, 100, 100, right? We hold that constant. Are we cool with that?
Mm-hmm.
And we hold all other relevant variables constant, and the amount of rainfall constant. Everything stays the same. We notice one odd thing. That if there's more sodium in the water, then you have more fluoride in the water. So as soon as I read that, I was like, well, that's really weird. If you hold everything constant, you're going to have more fluoride in the water when there's more sodium in the water. Sodium must be helping fluoride get in the water. Are you okay with that idea? So when it says, which of the following could be most reasonably concluded on the basis of this, D, sodium in the groundwater, because notice it was in the groundwater, increases the rate at which fluoride-bearing minerals dissolve. Oh, that would explain why there's more fluoride in the water. E is wrong, I think, for 2 reasons. One, it's talking about sodium-bearing minerals in the soil. And the other thing is it says contains high concentrations of fluoride-bearing minerals. We held fluoride-bearing minerals, I can't even say this, constant. So I don't understand how this can play a role in explaining the difference between places that have the same number of fluoride-bearing minerals. Yes, Rob.
I know this is kind of silly, but the next best answer on here, would that be A? Because it's just kind of like if you ignore the connection between.
Oh, like there's another source of fluoride?
Yeah.
Maybe.
I mean, the door's
but
open,
I'd still.
it's not as reasonable.
My concern with A was that even if there are other sources of fluoride, right, they said, let's hold all relevant variables constant. And so I'm like, okay, so even if there were other variables that had, or other things that had fluoride, they're being held constant. So why is there more when there's sodium?
Okay.
Yeah. Shelby, you okay?
I
I don't understand the subject matter, so I think it's just one I'm gonna have to just accept that I'm not gonna get. Like,
Okay.
I don't get why A wouldn't be right. Cause like, are we just supposed to like know that like, I guess in my head I was like, okay, if sodium can like make fluoride go up, isn't that like a source of the fluoride increase?
Oh, I don't think that's a source of fluoride. I think that is causing more of the same fluoride, or more of the fluoride-bearing minerals to release their fluoride. The thing about A is it doesn't even talk about sodium. So if you say sodium, fluoride-bearing minerals are not the primary source of fluoride, then you're sort of like, well, what is? Is it sodium? I don't know.
And I answered that with like, yes.
Yes, you said okay.
Yeah.
But yeah, so
Yeah, I just, yeah.
D is nice because it directly connects sodium to fluoride increase. Okay, that's fun.